Okay, so we'll start with our last module. As though some people are still making sure that gets set up on their system. So if you're while that's installing, I'll just quickly address some of the parts one part of the previous module we didn't look at and which we'll make use of in this section. So right in the previous module, we worked on reviewing some of the material you saw using the R Markdown, right? So that's the base notebook that comes with R. But what you'll notice is that now there's actually a more updated, more commonly used version. It's called Quarto. So that was developed by the same group that developed our studio. So the IDE we're working with. And so in general, it's just seen as an improved version of R Markdown. And what they mean by that is what you'll find is that a lot of the different documents you can generate from an R notebook, so say a slide deck, a website, or say an ebook, they actually require additional packages on top of having R Markdown in the first place. And what's great with Quarto is that a lot of those feature functionalities are just there by default once you have Quarto set up on your R Studio. So if you wanted to make a web page or so on, you can do that immediately, and you don't have to add additional packages to gain that functionality. Then what you'll see, what's great as well is it supports Python, R, Julia, and Observable. It's also compatible with different notebook formats. So, the same way, right, we've been working with an RMD file, you can actually use that. Also use a Quarto notebook, and also say if you worked with Python before, you can use a Jupyter notebook. So you can actually combine all of those under Quarto, and then you'll render your documents in the same space. Then yeah, so the activity that was here, we'll just use it as our toy example for the Git exercises we'll look at. And then we're actually going to try, I wanted to do the website. So we'll try and use the website and try and combine both. So the idea is by the end of this, you'll be able to use Git, and you'll have a toy example of a website you built out of R, which would be quite neat. So yeah, as mentioned, right, this is the Git and GitHub section. So the things we'll cover first is just looking at the version control system and working with Git. What we'll prioritize is learning how to manage what's called a local repository. So focusing on how to manage your versions of your files locally. And then adapting based off time, we'll look at extending that to a remote repository using GitHub and such, where we'll look at hosting the reports you made online. So the way I like to start this section, at least introducing Git, is with this little comic strip. So I'll give you guys a minute to go over it, and then let me know if there's anything you find is relevant or relatable in your past experience. I guess ask as a question: what's the key concern you notice with the grad students going through here? Any ideas? So I guess we're talking about a final document, right? So what could be the concern? If I start with final doc, and then I have final revision 2, and then final revision 8, and so on. So at the end, let's say a month from now, I want to actually use the final version of my document. Do you guys think it would be easy to find it? Not really, right? So they all have final, we'd expect to be like the last one, but given that they all have that term now, it's actually hard to figure out which version was what and what change was made, right?
Or it's 1 year thing.
Exactly, especially the more time in between, the even harder it gets, right? You'll always give it a name saying, I'll remember this is the one, and then a little time passes and you're not sure what it is. So, in this context, we're looking at one document, but as we mentioned, right, R is actually a combination of packages, and those packages are a combination of different scripts, right? So you can imagine if, let's say, I have a package that uses 10 different scripts or an analysis with 10 scripts, if I have to go through this process for every single one of those files, I'm never going to have something that's stable and reliable to work with, right? So I need a way to be able to track all of the changes I've made to my files, and easily be able to know what's the most recent version. And so this is where version control systems come in, right? So the main reason this has come into play is that it's a way to make it easier to document changes, all right? And so that allows for less confusion, and you can kind of treat it as a unlimited undo button. So then instead of having to try and rename files in a way that tells you what's the most recent one, a version control system is going to keep track of that and let you actually describe what those changes are. So an example of how that would work is with, let's say, a little text file here where you're keeping track of your groceries. Let's say, you make the first version of your list where you just add milk, and then maybe you extend it to include eggs, and that's now the second version of your grocery list. And then maybe later you add juice, and then you decide to take juice off to add soup. So, normally if you wanted to keep track of every version, you'd have 4 files here that are your groceries list with the different names. And then maybe eventually you can't tell which one's the most recent one anymore. And now what version controls allows you to do is to actually keep track of that and keep track of each change. So from your perspective, you're only really going to see this file here, but Git is aware of the fact that there's, 3 different versions behind it, and you know the order in which they come. So you can keep the same name for all of them, and you're not going to run into that issue where you can't tell which one is what. So in practice, there are a lot of different version control systems you can use, whether it's with R and so on. But what you'll find is the majority of people are working with Git. The main reason for that is it's an open source tool, and yeah, it's the most popular one that's in use at the moment. And the way it works is it's going to create what's called a Git repository, which is going to store all the modified instances of your project. So on your end as a user, so you're modifying your analysis script for your, let's say, a mixture of some R scripts with your functions and some notebooks showing the actual analysis. From your end, you're only going to have the final versions of those files present in your folder. And inside the repository, it's going to keep track of everything that was there before it. So if you had 10 different sets of changes, all of those changes are being tracked within the repository. And so on your end, you don't have to actually see all of those. It's managed by Git. Okay, so what kind of files does Git track? So it was designed with pure text files in mind. So that means that things like a .txt files, basically that you would use with, say, the Notepad, or any form of coding script. So an R Markdown file would work, a Quarto document works as well, and then all kinds of different scripts. So whether it's in R, Python, and so on. Some files that don't work great would be anything that's binary. So for example, if you take a Word document and try and look at what its contents actually are, you'll find it's all binary. So that's not really practical to using with Git, because now if you look at what the changes are, it's not actually telling you the change to a line. It's just telling you, a bunch of zeros and ones, which don't mean anything. Whereas, if I make a change in an R script, I'm going to see the actual change for what it is. So, if I added a function, I see that the function was added. So to some extent, it's still useful to use Git to store those files just to know what the version is, but you won't be able to actually check what the changes are between them. But at least it means you won't have 20 files called final. So there's that helps. So usually what's recommended, if you want to actually, store documents and such, you're going to make use of either some form of markdown. So the .rmd file would work quite well, or .qmd if you work with Quarto. Move this to the top. There we go. Or LaTeX documents work as well. So I don't know if any of you have worked with Overleaf before. I've heard of it. So if you write a LaTeX document in that, that can be stored in Git quite well, and you keep track of all of the changes. Okay, so now we mentioned that there's Git and GitHub, but a common misconception here, these are the same thing. So they're actually two distinct pieces of software. Software's not the right word. So Git is the version control system. And so that's something you can use on your computer or see on a remote server. And it's open source, and that's what's actually tracking the changes. So whenever I make a new version changes and store that in the Git repository, that's being handled by the Git software. Now, GitHub, on the other hand, is a server that's going to host the Git repository. So it itself isn't doing the version control. It's just providing you a remote computer that can run Git for you over there, and you can store your material on their server. So it works solely as a cloud-based service, and then it's owned by Microsoft, in contrast to Git being open source. Now, some just additional terms to be aware of. So there's 2 concepts to note. We mentioned this idea of the Git repository, and this shouldn't be confused with your working directory. So the working directory is what you're used to right now. You have a folder, and that folder is your working directory, right? Any file inside of it's present within the directory, and you can easily access it while you're working, say, on some code inside of the folder. The Git repository itself isn't a directory. It's actually a hidden file within that folder. So from the user end, usually you won't actually be able to see the Git repository itself, but all of the changes that are being tracked are going to be within that hidden file. And then whenever you try and change something or revert a change that you've made, it's going to come out of the Git repository to update the files you're seeing. And then the thing to note, there's 2 components to the Git repository. So there's what's called a staging area. And then afterwards, there's what we call the commit history or the local repository. So the staging area is where we prepare a change we want to be stored. So let's say we're making some modifications, but we're not done adding all the changes we want to do. We may add that file to the staging area. And then once we've finished making all of our changes, we're going to take everything in the staging area, and then we're going to make what's called a commit. And that's where we've actually stored it in our history. And then Git can actually revert back to that version. Okay, is there questions so far? Great. Okay, so here I made a quick diagram for you guys to see how each part works. So here on the left, right, is your working directory where, you're going to create your files and then you'll make your changes and so what. And the second part here is the Git repository, right, with the staging area and the local repository. I did not update these to .r, still says Python. Oops. Anyhow, so you can imagine, right, you started your new project, you made your directory, and then now you've created a new script, right? So because you haven't actually tracked any changes on this file yet, the Git's going to tell you that this is a new file, right? It's going to say, hey, I don't have a previous copy of this file. Do you want us to start tracking it? And so from your perspective, it'll tell you, hey, so this is new. Do you want it to be added? And so what you'll be able to do from your end is first add this to the staging area, right? So let's say you've made some modifications and you're trying to see whether you should make some additional changes. But in the meantime, you're going to store it in the staging area before you're ready to actually create this first version. Now, let's say once you're done with your changes and you think, all right, I debugged my code a bit, it's functional, at least not making any errors. You might say, all right, I'm happy to store this as the first version of the code and start tracking. So what you'll do at that point is what's called the commit. So what the commit does is going to take everything in your staging area and it's going to store it in the local repository. And so what happens now is that, whereas before, right, your code script was seen as, say, a new file that wasn't tracked, now Git's going to tell you that it's tracking that file. So it knows exactly what it looks like. And so if there's any change to it, let's say you changed a line or added a new function, it's going to tell you that there's a change in that file. So it may say, hey, look, there's a new file at line 10. There's a new value at line 10. And that doesn't match what was in the copy we have in the local repository. So now what you can do when that happens, right? Once you've made your new changes and you're happy with it, you can add it back to the staging area. And now you can commit it into the local repository. And so now from Git's perspective, it has these two versions of your files. So the initial one you made to start tracking, and then the next version with some of the modifications you've made. Okay. Is that clear for everyone? Anyone have questions? Great. So one thing you'll note, right? I mentioned the idea is that one thing you want to be able to do is not just see what the changes are, but sometimes you may have a lot of changes, right? So having to look at, say, maybe you've added 200 lines of code in one version. You may not want to sit there and go through the 200 lines of code to try and figure out what change was made. So something quite neat that comes with the Git is the commit messages. So whenever you make a commit, you have to add a message to describe what the change was. And the reason for this is that it makes it a lot easier to understand what happened. So, sometimes I don't need to know, oh, I added this function, which, who does this, and then I added this next line, this comment, and so on. What I may just be interested in is saying, okay, I added this feature. So let's say you modified your script to use to add a box plot, for example. So say, oh, hey, I added what your commit message would just be is say, hey, I changed this file in order to add a box plot to visualize whatever comparison you're doing in your analysis. And then from your perspective, that's a lot easier to understand instead of, say, reading let's say maybe the 50 lines of code you may have written to set that up. And then what's great is that, on your end, usually you know what kind of changes you've made, but if you're working with other people and they need to look at the previous versions, you want it to be easy for them to understand what happened. So to give you an example here of what, say, a bad Git commit would look like versus a good commit message. So you can see in the first place, we're just saying we've added a file, but that doesn't tell us what the file is actually doing and what its contents are supposed to represent. Whereas you can see in the second case here, we see, okay, there we go. I create user model to store user session information. So let's say down the run that someone comes back and says, hey, there's a problem with the user model. There's a lot of bugs with it. Whereas let's say your software didn't have bugs before, someone can just go through your commit messages and then say, okay, well, look, here's where we added it. So the problem must have started from here, right? And so you don't have the case where you have to say, oh, yeah, go ahead. Yeah, so the idea is just you're going to set some criteria for yourself based off what you're doing. So let's say your goal for this week in your project was, okay, I need to add some data processing so I can generate a table for my results. So then in that case, you may keep adding things to the staging area until you've achieved that goal, right? And so then once that's certain, now everything's functional, at least until that step. So now you're going to commit everything and you'd have a message that says, okay, finalized data processing, generated table, like summary table, right? And so now, from your case, oh, let's say later down the line, 6 months later, someone determines, hey, there's something wrong with the processing. So it's messing up the rest of your analysis. You know exactly when that change was made. But yeah, so usually some people, every change they make, they commit immediately. And then some other cases, you'll see that what they'll do is, okay, I'll commit at the end of my workday. So then you'll do whatever. And then, if nothing works, then it's not added. or, if it's functional, then you'll just commit that. So the criteria you set is more bit based off yourself, but usually the idea is that you have some set goal, and then once that's achieved, that's what you're going to commit. So that's stored. So what you may see, we'll talk about GitHub a bit later, which you'll see some people, you can see usually the frequency at which they commit. So you'll see some people, they make it, they edit like one word, they're going to commit it straight away. Whereas others, it maybe they're going to wait until the feature is complete before they add something. Okay, so we'll go with a quick poll before we move on to trying out some of the features. So these are just a set of true or false, just to see if you guys understand how things are working. So in the first case, both untracked and modified files must be added to the staging area before commit. So who thinks this is true? Anyone thinks this is false? Anyone unsure? Yeah, that's also okay. So in this case, right, it's true. So anything we want to commit needs to go through the staging area, right? So we can check again with the example here, right? We had this new file, we had to add it to the staging area. And then once that was committed, same idea after. Once we made a modification, we need to add it back to the staging area so we can commit. Okay, then next true or false here is, so GitHub is a type of version control system. So who thinks this is true? Who thinks it's false? Great, yeah, so it's false, right? So GitHub's the server on which is actually providing access to Git remotely, right? Git itself is the version control system. Then this last one, I guess I didn't emphasize the results, so you guys can just try and have a guess to see. So the repository keeps track of changes by storing each version of a file or project. Who thinks this is true? Feel free to take a guess with this one, that's fine. And who thinks this is false?
I think it's true.
That's fair. So in this case, it's actually false, right? So what Git actually does, in order to save a bit of space, instead of storing every single version of the file, it just stores the changes. So if we go back, well, there we go. So we look back at this example, right? We have those 4 states of our file. What the Git repository is actually storing is what's in red here, right? So it's the main only version of the file it'll store is this first one, R1, and then the rest of what the repository is storing are the changes in red. And so the idea is that whenever you add a specific version, what Git's doing is taking what's at R1 here and then adding up all the changes to create the final version of the document. And so the reason it does that is that it takes a lot less space, right? So, imagine, let's say you have a gigabyte of files that you're committing. That's a lot. You only really see that with a huge piece of software. You can imagine, let's say if I have 1,000 commits, all of a sudden, my Git repository has about a terabyte of data in it, which is huge. Whereas, if the focus is just on the changes themselves, you can save a considerable amount of space, and then it makes it a lot more efficient. Okay, so yeah, to summarize at least the core concepts that we're looking at here. Yeah, so untracked and modified files need to be added to the staging area. Then from there, once they're staged, you can actually commit them to the local repository. You remember with a message that describes what the change is. And then the key advantage the commits provide is that we can actually revert to a previous instance of the project if something goes wrong, or just keep track of what the changes are. So what's great is that, right, let's say you set up your analysis, everything's working, then all of a sudden something goes wrong, a weekend that messes up the entire code and you can't figure out where it is. If you have your commits made with the clear description of what's going on, you can always go back to a version that is functional. So you can imagine maybe, all your data processing is working and it's generating your plots, and all of a sudden you're getting errors which you can't explain. If you go back to your commit messages to a version that says, okay, finalized visualizations, no errors found at all, you can just go back to that commit and you're going to be safe, right? Okay, so with that, we're going to start trying out some of the basic Git features. Does anyone have more questions for me before we move on? Great. Okay, so in terms of accessing Git, there's 3 general ways. Most people will make use of it off the command line. What you'll find is that there's a considerable learning curve there if you have to learn how to make use of Unix, or say make use of PowerShell. So it's the most common way people use it, just because it's a lot more direct and it works on servers. And again, the main con you'll find there is the learning curve. A lot of others will use the desktop app, so GitHub desktop app. So what's quite nice there is that it's a graphical interface. So it makes it a bit easier to understand how the different functions are working and select them. And then the last setup you'll find is within a text editor or an IDE. So in our case, for some examples would be with VS Code or RStudio. So in our case, we're going to work with Git through RStudio. That way, we can work on everything in the same environment. Okay, so to access Git, first of all, was everyone who was installing it able to finalize the installation? Okay, great. So while that's getting sorted out, everyone else can focus on what's on the screen here. Then what we'll do in that case, so while some people are setting up, we'll start looking at the first activity. So getting this Git repository initialized. So for the sake of making this a bit more fun and putting a bit more stuff going on, what we're going to do is we'll try and initialize our new project with a Git repository, but we'll set up a Quarto website. So that way you guys get to see that functionality while you work on the version control. So I'll update the instruction after. For those who created it but didn't see the option, you should be able to click on the Tools tab once the project is created. And then there's an option called version control. So if you click that, there should be something that says set the version control system to Git, and then it should show up. Okay, so you have a very simple website, and you did that with one language. So technically, you can call yourself a full stack web developer, although the people in that field may not appreciate it. However, technically, you did go from start to finish. Now, in our case, right, we talked about setting a threshold for a commit. In our case, we hit that threshold, right? We have a functional web page using our code. So now we're probably ready to make a commit in the first place, right? So what we'll do in our case is you'll check under the Git tab and you'll see all of the untracked files that were generated in the process. Okay, so was everyone able to make at least the first commit? Everything worked there. And then, so yeah, for once that's done, any change you make, right, it's going to mark it as modified and then you can work around from there. Okay, great. So now that that's committed, I'm going to show you guys just a quick way to try and remove stuff that you've added. You may have a situation where maybe you want to add something new to the web page, but you don't want to break the version of the web page that's already up, right? But you still want to be able to work on it and test it. So the way people actually achieve that is with a branch. So the idea pretty much is that this acts as a kind of timeline for your commit history. So let's say we started here in what's called our main branch. So the web where their web page is present. We're going to work on adding let's say we set up the initial commit with our web page and then we found an issue. So we fix it in the next commit. Then we have, say, the first version, fully functional version of our web page, which we put up. Now, let's say you wanted to add an additional analysis without, messing up that current branch, that current setup. Here's where you can make a new branch. And so the idea is in that branch, you can start making additional changes, but it's not going to affect this version here. So you can have that publicly available version set up. And then I'd say locally and privately, you're able to work on a separate branch and make the changes. And then essentially once those are done, you're able to use what's called a merge to bring it back into the branch. So I have another diagram of that here. So let's say, right, the feature's finished and I want to add it back. You can merge that development branch into the main, and now that changes there, except you've had the time to test it properly without damaging it. And same idea, you may have something you added to the main web page, which would be useful for what you're doing in that development section. And you can actually merge that change back into the development branch. So you have the opportunity to make updates on both ends and in such a way, right, that they don't affect each other in the meantime until you've decided to combine them. And then beyond that, it's most of what you're going to use locally. And the main thing that's going to be left is how you want to collaborate with other people. So that's where GitHub comes in, right? So we mentioned it's a server that hosts Git. And so what happens, the next step is that you'll be able to actually push the changes you have or repository you have locally onto Git. And so let's say you're interacting with other people, instead of, say, sharing everything on, say, OneDrive, for example, you'd give them access to your GitHub repository. And then what they're going to be able to do is pull any changes that are made from in that repository to their local copy. So to wrap this up, I have a last diagram just to give a graphical way of seeing how that works. Right, so here's everything we've seen so far. right? We made a change and we're tracking our file. All GitHub is adding is this red section here, so that remote repository. So once we're ready to have everything stored up there, we're going to use what's called a push, and we can store the material there. And then a collaborator, can interact with that and make changes as well. And so let's say they find a suggestion to make and then push it to the repository as well. You can then add that into your local copy with the pull command and then store it here. And now you have the same version. So you'll see it's kind of this back and forth that's managed by what's happening in the GitHub repository. The examples in the exercise to do it are in the slide deck. Where, given time, unfortunately, won't be able to cover it. But at the very least, I hope you guys see the advantage of making use of this with R. And did I add the dinosaur image at the end? No, I didn't. So the hope is at least after this, you don't go back to writing 10 different final documents, and you just make use of Git, at least with your code, to make sure you don't lose the copy. And yeah, I guess would anyone have any questions, at least for now? Stay after as well if you want to discuss this a bit more. I guess we'll work on wrapping up around here.